KCC105. Welcome to our class for the winter term. My name is Professor Will Johnson. Looking forward to working with you. Our first video for this term, we're going to talk about linear growth. Look at those money bags. They're growing. Linear growth. Let's see how we can represent that. Set the stage. Representing quantities. If I just give you one number, $1 million, that number stays put. It doesn't change. But if I give you that number, $1 million, we can represent it, say, the stack of bills on the ground. If I say 200 people, we can represent that how maybe 4 city buses full of people. However, when things change, money definitely changes. When things change over time, we might need other ways to represent them. Here's a good example. A very common saying, we've all heard it. Another day, another dollar. Monday, Tuesday, Wednesday. You see what's going on. You see the pattern. So there's a saying to represent that. Another day, another dollar. There's these pictures to represent it. Those things are growing. How else could we represent it? Well, why not a graph? Every single day, my dollar bills get bigger. We can represent it that way. So look at this. The idea of change. We can use words. We could use pictures. We could use a graph. What else can we use? Well, here's some more specific examples. Each day my money increases. Every day my money increases. Underlying those words. Those words are big red flags. They should cue you off. We have some sort of linear change. My money changes by a constant amount. Those are all ways to talk about linear growth, change in these numbers. Let's look at a concrete example. Okay, I was just talking another day, another dollar, but what about a real life example? Pretend you're earning $12 an hour. Well, wait a minute. $12 an hour, you could say each hour my money increases. That's linear change. Every hour my money changes. My money changes by a constant amount, $12 an hour in this case. So what am I doing? I'm taking a real life example and I'm representing it through these words. How else could I represent it? Why not a table? If I work 1 hour, I earn $12. That's common sense, but you can see the idea that we're able to extend it. The number's changing, but I'm able to represent that. I work 2 hours, $24. I don't think there's anything mind-blowing about the numbers going on here. But what am I doing? I'm organizing the principles of change. Linear change in numbers. I'm able to write it as a word. I'm able to organize it in the table. What else am I able to do? Why not? We talked about a graph before. We could see that. 1 hour, $12. Say 4 hours, now I'm up to $48 rather. You get the idea. And also you'll notice in that graph, my money forms a straight line. So these are all things connected. If I'm talking about linear change, I'm talking about each, every, constant amount, slope of this line, the constant straight lines. I'm talking about the tables like we saw before. We could do an equation. Now, I know this might be a gut reaction. Oh my goodness, equations. I don't like equations. Don't worry, we're not going to really get into equations in this class, but I think everybody has seen this at some point in your mathematical career, whether it was last year or maybe several years in the past. But we've all seen this, that X and Y represent the two things I'm measuring, the time you work and the money you earn. And we can use, once again, a table, and we can do some math, basic math. 2 times 12 is $24. You can multiply to figure out, hey, I can predict in the future how much I'm going to earn. We could also work backwards and say, hey, if I got $6,000, I could divide it and say that's $500. $10,000, I got to work 833 hours. So you see what's going on is from this equation, from this table, I can predict what I'm going to earn in the future, and I could also represent those big numbers in terms of hours. The linear model, linear growth, change in my money lets me predict and it lets me represent. And that's what we want to get at in the homework. I was talking about your wage. Let's talk about something more creative, like a bus fitting people. So 5 buses is 250 people. You see what I did? I just multiplied by 50. I could say y equals 50x. I'm not going to do that. I'm just going to represent that. I'm going to do that multiplication in my head. I could say the opposite way around. I could say 2,500 people. Well, that's 50 buses. And you see what I did? I divided that number across 50 people per bus. If I say each year I earn $40,000, I could predict in the future. I could say 4 years is $160,000. I could also break it down. I could say $1 million is 25 years of salary. What am I doing in these creative examples? I'm taking the same thing you saw before with the graphs and the tables and everything, and I'm just either predicting in the future or I'm representing a big number. If I drink 2 sodas every day, predict in the future. 1 week, 14 sodas. Represent a big number. 1,000 sodas, that's 500 days. Or it's 1.36 years. You could break it down that way. If each pizza feeds 3 people, predict in the future 30 people are going to be fed with 10 pizzas. And also I can represent 40,000 people. Big, that's a football stadium. We need 13,000 pizzas to feed that. So what's the idea is that you're taking linear growth, linear change, every hour I earn $12, and you can either predict or you can represent using a table like that or using more creative examples like this. Why is this important that I'm showing you all these different ways to do that linear growth? Look at the homework. You are going to pick a number like 1,000,000 and you're going to represent it. You're going to pick linear growth. I said each bus is 50 people. You're going to pick your own thing. Each hour is this. Each day is this. I'll let you do it. You're going to try and create creative examples like this and apply them to sort of representing big numbers. Read through the homework, read through these instructions in more detail, and see what you can get. Obviously, I'm an email away because this might not be your typical math assignment. If you have questions, I'm more than willing to help. Please reach out. Looking forward to working with you for the term. Week number 1, see what you got. And any questions, send an email. Thank you.